Good morning students. Today we are in machine shop to discuss about the metal removal process experimentally. So this is the first machine which we are going to learn. So this machine name is lathe. By this machine we are reducing the diameter of a bar. You can see here this is the typical object which you can see here the diameter of the bar has been reduced in steps. So this particular process is called as turning. So this machine shop will do, or this particular machine will use to reduce the diameter of a material of a round bar with steps. Now we will go into the machine, or we will see the different parts of this machine to understand that how this machine works. Start from this most of the left hand side. This is called as the headstock of the machine. Here in this headstock there is an arrangement of gears are there, which you can compare this thing as with a gear train. So there is different arrangement or different set of the gear, which we'll often call it as a tumbler gear mechanism. So with this particular set of the gear, what we can do, we can change the speed of the output with the machine. What is the machine power is coming input here. You can see here 3-phase machine inputs are there. With that input it is coming, the power is coming to there, and with the change, with that especially rotating knobs, we can change the gearing ratio, and with that the output is coming here, or output rotation is coming here, and with that we can use or we can achieve different speed. Now different speed is required for different material. Suppose some material we need to do it in a low machining speed or high machining speed, that entirely we can do it by regulating with different gear mechanism. Now coming to here, this is called as a chuck. You can see here there are 4 jaws are there. So this is like 4 jaw chuck. Similarly there is another type of chuck which is 3 jaw chuck. So chuck is basically to hold the material. Suppose this is the material and you want to hold it over there at the center. So what we will do, we will adjust this chuck legs so that it will come and it will hold this particular machine or particular workpiece or the job which we are talking about. So here this chuck is 2 types, like some is self-centering chuck and some is for this legs can be automatically adjust or individually adjust to hold a irregular shape of object. But in this class we will do some regular shape of job, that is we are reducing the diameter of the bar, that is with the turning process. You can see here the bar with the different steps we have done. So this has been done with the turning process. So before going to this process, let us discuss some more about the machine. So now we are coming to the latter part or the right hand side of that machine. This is known as the tailstock of the machine. This is basically to hold the job, and the center which is here, which is known as a dead center, because it is giving only supporting, it is, that's why it is talked as a, or it is known as a dead center. And now we are coming to the other part. This is called as a carriage, and here in this carriage, with this carriage we can particularly hold that particular cutting tool. So this is a machine tool and this is a cutting tool. This is the cutting tool through which we will cut the this particular job. This is the workpiece and this is the cutting tool. So with this cutting tool we are basically going to cut this job. So this is called as a single point cutting tool. As you can see, it is only one cutting point is there. So this is called as a single point cutting tool, and with that tool we can reduce the diameter of the job stepwise. And then before that, what we have to do, we have to hold this particular cutting tool. That we can hold is through this particular attachment which is called as a tool holder. With tool holder we can hold this cutting tool and eventually we can cut this particular steel rod or steel bar, and that can be attached with this carriage, and this carriage can be moved or can be slide over this entire portion on the feed rod. You can see this is the feed rod and this is the lead screw. 2 different attachments or 2 different rods are there. So this mechanism or this total carriage can be moved from left to right on this particular feed rod, and also one lead screw is there. When we'll see the threading operation, I'll come just a little bit later, then we can see the use of the feed rod. Now the next thing is this mechanism, whatever inside this particular carriage is there, that is known as apron mechanism. With that mechanism, by changing this particular lever wheel and all, we can see it can be moved from either left or right. And now coming to the different operation of basically of this process. Now you can see there are many operations which can be done through this particular system. And before going to operation, we will see another thing. This is the thing, this is the one part, it is called as a lathe bed, where all the system like headstock, tailstock, carriage, everything is situated. This is called as a lathe bed. It is often made of a cast iron, and this is because cast iron has the most, it is strong in compression, that's why it is made of a cast iron, and with that the total system is resided on your this basically lathe bed, and that is the chip tray. So whatever the chip will come out when we will do the cutting operation, that will be collected in a chip tray. Now we will come to the different operation. As you know that in machining operation or in this particular turning operation, there are a lot of operation can be done with this particular machine. That is turning, facing, taper turning, thread cutting, knurling. There are a list of operations. So among them, few are the operations which we will see in this particular practical session. Few operation I am telling now itself, that is the reducing the diameter of the bar, which is called as a turning operation. We will do it with this particular single point turning tool, and that will be operated basically stepwise to reducing the diameter. That is called as a turning operation. Now apart from the turning, there is other operation, that is taper turning. You can see here that a taper particularly at that end, a taper has been made. So taper turning operation can also be done through this machine. The taper turning, there are different methods of the taper turning, doing the taper turning operation. Few of the methods are offsetting the tailstock, then rotation of this compound slide, then also using form tool, or there are the different operations. So in this case, we'll do the rotation of the compound slide, and we'll do the taper turning operation. So these are the two operations. Then third operation is your thread cutting. You can see here it is a thread has been made. So this thread is of your metric thread has been made, and for that a special cutting tool is required, that is equal edge. You can see there it is a little bit different from this. So it has the equal cutting, because for thread cutting these both edge are equal responsible for the cutting, whereas for the turning only this edge, which is known as primary cutting edge, that is only responsible for your turning operation. But here for thread cutting, both the edges primary as secondary will be equally responsible for the thread cutting operation. And for that thread cutting operation, what we will do, we will engage a half nut. So that mechanism will be a little bit changed when we will discuss about practical process. I will show you, but now I am telling you that half nut mechanism is there, by which this will be engaged to this particular lead screw. So lead screw will take power from your headstock. So while lead screw will rotate, this particular carriage will move automatically, and the thread will be cut with automatically on this particular round or particular this bar. So these are the operations which are going to do in this particular process or particular experiment. And the last operation is the knurling operation. You can see the knurling tool or the knurling process. After knurling, what are the surface will be, and you can see here that it is basically with the knurling it is better for the gripping operation, and with the knurling tool we are specifically using, which is not here, I will show when the experiment will go on. So with that knurling tool we can do the knurling operation also. So these are the basic parts of your lathe, and with this machine will be engaged to do all these operation which I have shown. But apart from this operation, there are several other operations like facing and all the operation which can also be done through this lathe, and it is used as a versatile machine because it is used in most of the workshop practices. So those it can be explored further, but for this class we are going to observe this particular operation in practical, which we will see in the next machine. So we will do now experimental process through this machine. This is similar, this is a lathe. So this is the workpiece which we are going to reduce the diameter of the workpiece in steps. So basically we are going to do step turning. So for reducing the diameter, two different motion is required: primary cutting motion and secondary cutting motion. So primary cutting motion will be given through this particular headstock, and after that whichever I have shown earlier. So this is the chuck. So this is called as a 3-jaw self-centering chuck. With that we are holding the regular shape object. As it is a regular shape object, so we are holding with the 3-jaw self-centering chuck. Now you are seeing he is adjusting the chuck so that it will be perfectly centered or perfectly aligned with your central axis of the operation. Now the tool has been held with the tool holder, and the feed is given in a stepwise so that we can do the step turning operation. Yeah, first operation is the facing operation. Facing operation has been done to have a clear surface at the end. So first operation is the facing operation which we are doing. You can see the facing operation. So facing operation basically from the outside diameter, the tool has been taken from at the center, so it is giving kind of a radial feed to the system, so that at the end the surface will be like it will be very smooth surface. So here you can see from the center a feed has been given and it is taking to the outside. So this is the facing operation has been completed, and you can see that now the surface is like it is glittering. So the surface is now very smooth. Now we'll start the turning operation. So each movement will give some amount of feed, and you can see the will give just the longitudinal motion, and the rotational motion is given by the headstock on the material or on the workpiece, which is called as a primary cutting motion, and secondary cutting motion is given by that particular tool with the feed mechanism, and only the longitudinal motion has been given with a particular depth of cut, so that the material is being cut or it is being turned and the diameter of the workpiece is eventually reducing. So turning operation you can see now. So 1 millimeter depth of cut has been given. Now again 1 millimeter is giving. So in this way the diameter is reducing by giving a depth of cut of 1 millimeter at each step. So each time the diameter of the workpiece is reduced by its depth of cut, whatever it has been given to it, and the new surface from the inside it is being revealed. So whatever the particle it's producing, it is called as a chip, it is at the high temperature at this moment. So while doing the operation, you should be very careful about the chip and all. So this has been done the first step. Then second step, it has been cut, second step. So you can see now basically the diameter of the circular bar is reducing by an amount which has been provided through depth of cut. Now the second step is being cut by providing the depth of cut or the increasing the depth of cut at each step or every step. The second step has been made now, or second step shaft has been made. Now the third step is coming. So basically it will be 3 steps as I have shown the workpiece earlier. So it is just a reduction of the diameter in 3 steps. So this is the third step, it is being done. So it is continuously reducing its diameter in step, and this process is called as the step turning. Okay, now this is the final step turn. Now you can see in detail that there is a shaft has been produced in different steps. So this is done. This has been done with the step turning operation by increasing the depth of feed or depth of cut at each step by some amount, let's say 1 millimeter. So this is the first operation which we have demonstrated in the lathe. Now going for the next operation. So now taper turning operation will be done. As I have told that taper turning operation can be done in different procedure, like taper turning operation can be done in different process. One is tailstock offset method, something is like rotating your compound slide, and another one is the using form tool. So in this method we are using that rotating the compound slide. Now you can see here the compound slide has been rotated by a definite amount in which the tapered has been, by which angle the tapered has been made, and we are giving feed at we are giving depth of cut at each step so that the taper can be made. Now you can see that taper is being made at each step. So he is increasing the depth of cut each step so that taper will be becoming prominent and it can be visible. Okay, you can see that process, that he is rotating the compound slide so that it is the tool will move in that inclined path and the taper is being turned and the taper turning operation is being done and the depth of cut has been given through the compound slide and or the cross slide, not the compound slide. With the cross slide the depth of cut has been given and the movement of the slide has been given through this, that is the compound with that cross slide. So this is the taper turning operation and you can see that a beautiful taper has been formed with this taper turning operation. Now we will go for the next process. So you can see that this is a knurling tool. So basically it is a kind of a cutter, so that this whatever that groove is there, accordingly that impression will be created on your workpiece while it will be attached with this tool holder. Now you see the knurling operation. So before knurling, he is just cleaning the surface by doing the straight turning operation. Okay, now knurling tool is being held through the tool post. Now knurling operation will be done and it has been held through the tool post. The job has been held to the tool has been held, the knurling tool has been held through the tool post. Now the knurling operation is being done. You can see the operation. So this is the knurling operation in which the tool impression is created on the job, so that that portion will be easy to handle and some rough surface will be created. Okay, now you can see the surface. Surface has been knurled, and so that it is very easy to now hold and handle safely. So knurling and taper turning are side by side, and also you can see that it is a job with the step turning, or we can say straight turning at different step. So the step turning turned object has been prepared, and this is, and this end what is there, it is for the taper turning, which we have done by rotating the compound slide and moving the compound slide in that direction, and this is called as a knurling. So three operations which we have seen here, and also before doing this thing we have clean this surface by doing the facing operation by the turning tool itself, on which the tool has been taken to the center, and from there it has taken outside or towards the periphery, so that the surface will be face, or it will give a clean surface. So now we will see the thread cutting mechanism. For that thread cutting mechanism, what we will do, we will change the gear train. Now you can see this is a typical gear train which is there inside the headstock. So we will change the thread cutting mechanism, we will change the gear train, so that automatically the feed will be given to the lead screw with the help of half turn mechanism. Now here, before engaging that, we want to say that we want to create one thread of 16 TPI, means 16 thread per inch, it is called as a TPI. So with that, there is some standard is given there in that list. You can see here in that list that some standard has been already given. Through that we can see that how much for TPI is 16 and what is the gearing ratio you should engage. So for 16, 32, 64 is the gearing thing which we have to do inside the headstock. So it has already been done in the headstock. Now this is the half nut mechanism or half nut, which will, if we will half nut, it is saying because half of the nut, if we will engage it, then the total carriage will move automatically on this particular lathe. Now we will engage the half nut and we will see the operation. Now half nut is engaged. Now you can see that compound slide is moving automatically on the field or on the lathe bed. So this will be helpful for our thread cutting operation, because for thread cutting for thread cutting operation, the thread cutting is nothing but creating one helix. So helix is basically from one point when it is starting, from next point it should start with that same point, otherwise there will be overlapping of the helix will be done and you will lose the thread. That's why we will engage the half nut mechanism, so that this cross slide will move automatically and will mark the initial portion, and each and every time after the feed will start from that point itself, so that that helix will be repeated with a constant amount of depth of cut which will given through that. With that we can get a permanent or a prominent helix. Now we can see the operation part wise. Now the half nut mechanism will be engaged. Yeah, so first helix has been done. Now the second helix has been started from that same point. That point only you have to mark that it should start from that same point, so that it will start moving that in that path, in that same helix from that point onwards. Yeah. So basically we are doing turning on the same path itself by increasing the depth of cut. Basically we are imprinting one helix on that round bar. Yeah. Okay, so few cuts has been given, and you can see that the helix has been formed. Helix is basically nothing but a thread which has been cut on that turning or on that particular shaft, and you can see a smooth object has been formed. And for that helix, only thing you should take care that it should start from that equal point or that from the same point onwards, otherwise there will be overlapping of the helix. So this is the thread cutting operation. So the difference between thread cutting and other operation is that for the thread cutting you need to engage the half nut, which will give the automatic feed to your carriage, and with that you just only regulate the depth of cut and you can get this nice kind of helix or nice kind of thread on your particular bar. These are the some of the operation which we have seen through lathe, but there are few more operations are there which can be shown or which can be done in lathe. There are few others operation also, but this operation is for the laboratory purposes of demonstration of the lathe. Thank you. Okay, these are the basic some lathe process which we have seen. First one is the straight turning in a step mode, which is called as a step turning also. You can see here it is a diameter, initial diameter of something like 30. From that a diameter or a single bar of 28 mm diameter we have prepared. After that it has stepwise it is reduced the diameter of 25, 20, then 15. So this is the step turning operation which has done by the with the help of the straight turning operation. Now next is there are different operation, but among them the taper turning operation which we have done here by rotating our compound slide. So this is the taper turning, or this is the typical taper which we have turned with a particular length of 45, so that outside diameter or the bigger end diameter is 25 and smaller end is 10, and with that what is the taper angle, it can be easily calculated. And these are the other two operations which we have seen. That first one is the knurling, to get that type of surface which is very rough surface and easy to handle, and this is the threading operation for which we have generated a thread of 16 TPI or 16 thread per inch. With that particularly you are creating one helix on that particular circular shaft or circular bar, and as we have told that half nut mechanism is required to do, or engagement of the half nut mechanism is required to create this kind of helix or this kind of thread. So this is the different operation which we have seen through lathe demonstration. Thank you.